It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe.
You will have a very, very hard time doing that. So to control these almost non-deterministic things,
I've been worried about every little bolt that goes into this.
NASA has just revealed new images from the James Webb Space Telescope, and they're not just stunning, they're downright chilling. These snapshots go beyond beauty, exposing details of a universe far more chaotic and mysterious than we ever imagined. Among them, a cosmic collision that could mirror the fate of our own galaxy. But this isn't just about what's out there, it's about what it means for us. Let us dive deeper into these revelations and uncover the unsettling truths they might hold. The James Webb's journey. They wanted to see farther into space than ever before, beyond what the Hubble Space Telescope could handle. Enter the James Webb Space Telescope. It's not just some random gadget, it's humanity's ultimate space peeping tool. It's built to study galaxies from over 13 billion years ago, right after the Big Bang. That's older than your grandparents' grandparents times a billion. But the first images revealed something unexpected, signals that didn't fit. The truth could change everything we know about the cosmos. This telescope wasn't slapped together overnight. It's the result of decades of brainstorming, designing, building, and sheer perseverance.
There are people that have literally spent their careers working on this telescope, their entire careers.
NASA teamed up with the Canadian and European space agencies to make it happen. And here's a fun fact. This thing costs way more than your average science fair project. We're talking billions, a jaw-dropping amount of cash, all to look at tiny dots of light billions of miles away. The James Webb Space Telescope launched into space about 3 years ago, setting up shop roughly 930,000 miles from Earth. That's a distance you can't even wrap your head around. Unlike most satellites that hang out in orbit, this telescope chills out by the Sun-Earth Lagrange point, where gravitational forces balance things out perfectly. Think of it as a cosmic sweet spot. One of the recent snapshots was dubbed the penguin and the egg because, well, scientists like giving poetic names to mysterious blobs of light. Let's talk hardware for a moment, because this telescope is no basic setup. Its primary mirror is a 6.5-meter wide beast made of 18 hexagonal segments coated in gold. Why gold? Because it's great at reflecting infrared light, the kind of light the human eye can't see, but this telescope devours like candy. The whole setup is like a giant, shiny sunflower staring into the abyss. Then there's the sun shield, a 5-layered contraption about the size of a tennis court.
This is the hardest, most complex telescope humanity has ever built.
Imagine a super sunscreen that keeps the telescope's instruments cool by blocking heat from the sun. This thing's so effective, it keeps temperatures down to minus 233 degrees Celsius. That's colder than your freezer times 100. What's the big deal about staying cold? It's all about infrared signals. These faint heat signatures from distant galaxies would get drowned out if the telescope weren't kept ridiculously cool. Thanks to the sun shield, the James Webb Space Telescope can detect the faintest glimmers of heat from objects billions of light years away. The telescope's scientific instruments take it from there. There's a near-infrared camera, a mid-infrared instrument, and a few other fancy gadgets that collect and analyze light. Together, they let scientists study everything from baby stars forming to the atmospheres of planets outside our solar system. In short, this telescope is the Swiss Army knife of space exploration. The images returned from the James Webb Space Telescope are not what human eyes would perceive directly. These are data captured from light in wavelengths beyond the visible spectrum. Scientists take this data and convert it into colors that make sense to us, like turning radio static into a melody. The results are breathtaking but also unsettling. With every image, new questions emerge. Consider the so-called penguin and egg images. At first glance, these shapes appear whimsical, almost playful, but a closer look reveals peculiar details. Strange formations and unusual patterns of light spark curiosity and unease. They suggest the presence of forces and phenomena not yet fully understood. Are these simply natural cosmic events, or could they be glimpses of something beyond human comprehension? This mystery extends beyond a single image. Since its launch, the telescope has been revealing astonishing sights. Distant galaxies take on spiral shapes, Stars exhibit movements that defy current explanations, and water vapor has been detected on planets that might support life. Each discovery feels like a cosmic challenge, urging humanity to unravel the universe's secrets. The insights gained are not without their implications. As knowledge of the universe expands, so does an awareness of Earth's fragility. Observing distant galaxies inspires awe, but it also serves as a humbling reminder of humanity's small place in the cosmos. These findings may not scream immediate danger, but they raise profound questions. If humanity is not alone in the universe, what might that mean? And if other forms of life exist, is it wise to draw their attention? The James Webb Space Telescope is not just a window into the depths of space. It is a mirror reflecting both the grandeur and the vulnerability of life on Earth, inviting reflection on the mysteries that remain. But let's keep unpacking this. The James Webb Space Telescope doesn't just deliver snapshots. It delivers revelations. Each photo, each data set is like a breadcrumb, leading scientists closer to understanding the fabric of the cosmos.
This is going to be the next big thing for astrophysics.
Consider the telescope's ability to peer into dusty regions of space where stars are born. These star-forming regions are like cosmic nurseries, and the James Webb Space Telescope's infrared vision allows us to see through the haze to witness the very beginnings of stellar life cycles. The telescope's focus isn't limited to distant galaxies. It's also giving us a closer look at exoplanets, planets outside our solar system. By studying the light that passes through their atmospheres, the James Webb Space Telescope can detect molecules like water, methane, and carbon dioxide. These are the chemical signatures that could hint at the possibility of life. Imagine discovering a planet with conditions similar to Earth's. It's not just science fiction anymore, it's within reach. Building a telescope for space is no small task. Every detail had to be perfect. Cosmic vision. The James Webb Space Telescope's journey to uncover the universe's secrets isn't without challenges. Operating a telescope so far from Earth means there's no room for error. Every component, from the gold-coated mirrors to the intricate sunshield, had to be designed to perfection. Once launched, there's no sending a repair crew if something goes wrong. It's a testament to human ingenuity that the telescope functions so flawlessly in such a hostile environment. The universe is vast, mysterious, and endlessly fascinating. The James Webb Space Telescope gives us a front-row seat to the greatest show ever, the unfolding story of existence itself. From the tiniest details of exoplanet atmospheres to the grandest structures of distant galaxies, this telescope is transforming our understanding of the cosmos. The James Webb Space Telescope isn't just a tool for scientists. It's a beacon of curiosity, a symbol of humanity's insatiable desire to explore, to learn, and to understand. And as it continues to gaze into the depths of space, who knows what secrets it will uncover next? NASA just dropped some seriously jaw-dropping pics from the James Webb Space Telescope, and honestly, they're as mind-blowing as they are kind of unsettling. This isn't your average telescope snapping a few cute moonshots. The Webb is looking back in time, showing us stuff that happened over 13 billion years ago, around when the universe was just figuring out how to be a universe. But before anyone panics and starts Googling how to survive a cosmic catastrophe, let's unpack what's going on here in a way that's not all sciencey and confusing. First off, the James Webb Telescope works differently from your backyard stargazing gadget. It collects light in a bunch of different wavelengths that human eyes can't see. Then NASA applies advanced techniques to the data so we can actually make sense of the pictures.
Is this the kind of stuff that keeps me up at night? Yes, this is the stuff that keeps me up at night.
It's not a simple point-and-shoot deal. These images go through serious digital processing. Noise gets filtered out, different exposures are combined, and every single detail, from stars to galaxies, is sharpened to perfection. It's like editing a photo, except it's of the entire universe. And it takes top-tier computer power and expert skills. Now here's the wild part. The telescope doesn't just take pretty pictures. It's basically a time machine. By catching light that's been traveling for over 13 billion years, Webb is giving us a sneak peek at how the universe started. But it's not showing the Big Bang explosion itself. Instead, it's capturing galaxies and stars that popped up a few 100 million years after the whole thing went boom. That's like looking at a baby photo of the universe, except this baby has been sitting in a cosmic photo album for eons. To make this happen, NASA launched Webb on December 25, 2021, after what felt like forever in planning and prep. They used a rocket, courtesy of the European Space Agency, from a spaceport in French Guiana. And talk about high stakes. There was zero room for error, but it worked. Webb cruised to its new home, a spot called the Second Lagrange Point, or LTWO. It's a primo location where the gravitational pulls of the Earth and Sun balance out, letting the telescope stay put without guzzling fuel. Once there, Webb had to unfold itself like a super complicated piece of cosmic origami. Its giant sun shield popped open to block heat from the sun, and the mirror, which is kind of like the telescope's eye, aligned itself perfectly. This wasn't just cool to watch, it was nerve-wracking. One wrong move and billions of dollars of science would have been toast. But it all worked, and by July 2022, NASA was showing off Webb's first official snapshots. These weren't just any pictures. The very first one was a deep field image showing galaxies billions of light years away. Think about that. Light from those galaxies has been traveling since before our planet even existed. Another shot showed the Southern Ring Nebula, where a dying star is putting on one last big light show. There's also a photo of Stephan's Quintet, a group of 5 galaxies hanging out together, about 290 million light years from us. Each of these images isn't just pretty, they're packed with information about how stars and galaxies form, evolve, and eventually fizzle out. What makes Webb such a big deal? Why couldn't our trusty Hubble Space Telescope handle all this? Well, Hubble's been around since 1990, floating about 310 miles above Earth. While it snaps some of the most iconic space photos, it mostly works in visible and ultraviolet light, which is great for certain things, but not for peering through cosmic dust clouds or seeing the faintest, oldest stuff in the universe.
2006.
I've been working on it for 20 years.
For 13 years.
Webb, on the other hand, specializes in infrared light, which can cut through dust and show us what's hiding. Basically, Webb and Hubble are like teammates, each with their own strengths. But when it comes to digging into the universe's deep history, Webb is the MVP. The universe looks peaceful and majestic in those images, but what they're showing is a place of constant chaos and change. Stars are born and die, galaxies collide and merge, and black holes sit in the middle of it all, consuming everything that comes too close. It's a humbling reminder that our cozy little planet is just a tiny speck in a universe that's been around for billions of years and will probably keep going long after we're gone. Webb's discoveries aren't just amazing, they're changing how we see our place in the universe. The universe through a golden mirror. The James Webb Space Telescope is doing way more than just taking cool pictures. It's rewriting the story of how the universe began and where it's headed. It's opening up new questions about life, time, and the nature of everything around us. This is both amazing and a little unnerving. But isn't that what makes it so exciting? The James Webb Space Telescope has been making remarkable discoveries since its launch. Recently, it captured images that have left scientists deeply puzzled. These photos reveal scenes from the distant cosmos that challenge current understanding and spark questions about the unknown mysteries of space. The extraordinary findings raise a profound question. Is humanity prepared to confront what lies beyond? The James Webb Space Telescope stands out for its exceptional capabilities. Unlike the Hubble Space Telescope, which has been a reliable tool for space exploration for decades, James Webb offers a groundbreaking leap in technology. Its enormous gold-coated mirror spans over 21 feet, enabling it to capture faint and distant objects with unmatched precision. This advanced design allows it to detect light that has been stretched into the infrared spectrum as the universe expands. Hubble, by comparison, primarily observes visible and ultraviolet light, which limits its ability to study the farthest reaches of the cosmos. These recent discoveries underscore the transformative impact of the James Webb Space Telescope. Its ability to peer into the depths of the universe is not only expanding knowledge, but also reshaping humanity's perception of existence in the vast expanse of space. Another standout feature is its location. Hubble orbits the Earth, which means it has to deal with sunlight and the planet's glare interrupting its view. Webb, however, hangs out over 1 million miles away at the Second Lagrange Point, or LTU. This strategic spot allows it to stay super cold, shielded from heat and light, essential for detecting faint infrared signals. In short, Webb operates in the perfect environment to do what it does best, uncovering the unseen corners of the universe. While Hubble has given us breathtaking views of the cosmos,
And then it deploys once it gets into space.
It's an origami telescope.
it's not equipped to see the earliest galaxies formed after the Big Bang. That's where Webb comes in. Its ability to detect faint infrared light allows it to look back over 13 billion years, essentially capturing snapshots of the universe's earliest moments. Hubble's smaller mirror and shorter wavelength sensitivity just aren't enough for these tasks. One of Webb's most talked about recent images is nicknamed the Penguin and the Egg. Despite the cute moniker, this picture showcases a dramatic interaction between two galaxies. Officially known as ARP 142, these galaxies are located more than 300 million light-years away in the Hydra constellation. The Penguin is a spiral galaxy, NGC 2936, which has been distorted by its close encounter with a compact elliptical galaxy, NGC 2937, the Egg, for the past 25 to 75 million years. These two have been engaged in a gravitational dance, twisting and pulling at each other's structures. The result is a visual spectacle, with the Penguin's spiral arms forming features resembling a bird's head and beak, while stars and gas stretch between the two galaxies. This cosmic collision isn't just a pretty picture. It's a glimpse into the fate of galaxies like our own Milky Way, which will eventually collide with the Andromeda Galaxy. As the Penguin and Egg continue their interaction, they're set to merge into a single galaxy over the next few 100 million years. This merging process has already triggered bursts of star formation in the Penguin's tail and beak, areas where gas is compressed. Meanwhile, the Egg remains relatively unchanged due to its older, gas-poor composition. It's been spotting some of the first galaxies ever formed, dating back over 13 billion years to just hundreds of millions of years after the Big Bang. These discoveries let us see light that's been traveling across the universe for almost its entire history. Webb has also become a critical tool for studying exoplanets, planets orbiting stars outside our solar system. By analyzing the atmospheres of these distant worlds, the telescope has detected water vapor, carbon dioxide, and other chemicals hinting at the possibility of life. One notable discovery came from the gas giant WASP-96b. Webb identified clear signs of water in its atmosphere. While this planet is far from habitable due to its extreme heat, the finding highlights Webb's extraordinary sensitivity. These breakthroughs bring us closer to identifying planets capable of supporting life, a monumental step in humanity's search for extraterrestrial worlds. The telescope's achievements aren't limited to exoplanets. It's also transforming our understanding of how stars and planets form. By observing regions like the Carina Nebula, Webb offers unprecedented views of stellar nurseries where stars and planetary systems are born. The details it provides are helping astronomers piece together the complex processes shaping the cosmos. Webb has also turned its gaze toward the enigmatic phenomenon of black holes. Observing the cores of distant galaxies, it has captured evidence of powerful energy jets emitted by supermassive black holes. These jets influence the growth and evolution of galaxies, and Webb's observations are helping scientists better understand the intricate relationship between these massive objects and their host galaxies. What if black holes, dark energy, and exoplanets hold the key to understanding our existence? Share your thoughts in the comments, and don't forget to like and subscribe for more insights.